Einstein's Relativity, the Special Theory and the General Theory. Chapter 1. Geometry and Physics. Surely you too, my dear reader, must have gotten to know the majestic tower of Euclid's geometry as a schoolchild, and it is perhaps with not so much love as reverence that you now remember its magnificent structure. You must also remember being chased around on its lofty stairways by your dutiful teachers for so many hours. Because of this past experience, you would certainly regard anyone with disdain if they declared even the most insignificant proposition of this science to be untrue. But you will likely lose this feeling of absolute confidence as soon as someone asks you, "What do you mean then by the assertion that these propositions are true?" Let us begin by giving a little thought to this question. Geometry is based on certain elementary constructs or concepts such as plane, point, and straight line, to which we associate more or less natural and intuitive meanings. Furthermore, it is based on a certain additional set of simple and basic propositions, i.e. axioms, which we are willing to accept unconditionally as true in view of these elementary concepts. All other propositions, theorems, are then attempted to be reduced to these axioms, using a generally accepted logical method. A proposition is correct or true, or in other words, it is proven if it can be derived from the axioms in this manner. The question of the truth of an individual geometrical proposition thus leads back to the question of the truth of the axioms themselves. But it has long been known that the question of whether an axiom is true is not only unanswerable by the methods of geometry, but it is also in itself without any significance. It is not possible to ask whether it is true that only one straight line passes through 2 points. It can only be stated that Euclidean geometry deals with constructs which it calls straight lines, and that it attributes to the straight line the property of being uniquely determined by 2 of its points. The concept of true that we are familiar with does not really apply to the propositions of pure geometry, because we are, in general, so accustomed to using the word true to ultimately indicate the correspondence with a real object. Geometry, however, is not concerned with the relationships of its constructs with the objects of experience, but only with their logical connections with each other.